Alright, let's look at a simple example of how to use the candidates test to find absolute extrema on an interval for a given function. We're going to look at the function f of x equals x squared minus 4x plus 5. Now we know that that's a parabola. We know that it should open upward, so it has its vertex at a minimum point. What we want to see is that minimum point on our interval? And if so, what is it? And if not, then what is the minimum value on our interval? Okay. So remember, for the candidates test, we said that the first thing we want to do is find any places where the derivative is either 0 or undefined. So that would mean that I have to start by taking the derivative. So if f of x is x squared minus 4x plus 5, then the derivative, f prime of x, would be 2x minus 4. Now I want to take that derivative and set it equal to 0 or find any places where it's undefined. Notice it is a linear equation, so we know that it's defined everywhere. So we don't have to worry about undefined. All we have to worry about is where it is equal to 0, which is 2x minus 4 equals 0. I can easily solve that equation and find that x equals 2. So when x equals 2, this function will have a horizontal tangent line. Notice that 2 is in the interval we're interested in. If it were not, we could ignore it. But since it is between 0 and 7, then we have to consider it as a candidate for either the minimum or maximum value. So what we're going to do now is create a table of x's and y's. We have 3 candidates for the minimum and maximum. One is the left endpoint at 0. One is the place where the derivative is 0, which is when x equals 2. And the last is the right endpoint, which is 7. Now I'll take each of those values and plug them in to the original function, not to the derivative. Make sure you plug them into the original function. So when I plug in 0, 0 squared is 0. 4 times 0 is still 0. Plus 5, I get 5 for my answer. Okay, I would repeat that process with 2. 2 squared is 4. 4 times 2 is 8. 4 minus 8 is negative 4. And then when I add 5 to that, I get positive 1. And finally with 7, I won't write this one out, but 7 squared is 49. 7 times 4 is 28. When I subtract, I get 21. Plus 5 is 26. So now I can see that I have 3 options. 0, 5 is neither a minimum or a maximum because 1 is less than 5 and 26 is greater than 5. So I see that I have a minimum at 2, 1, and I have a maximum at 7, 26.